Earlier, we learned about functions. We saw how functions provide a relationship between input and output. Now, to do this whole process mathematically, we use function notation. Yes. Hello math learners, Hassan here. Welcome back to our Algebra 1 journey. In this video, we are delving into function notation. For the function, most of the times we use the notation f of x, also called the function notation. And this is another name for y. This notation is read as the value of f at x or f of x. The parentheses over here do not imply multiplication. So do not get confused with this notation over here. We can use letters other than f to name a function. Remember over here, f is just a letter to name a function. We can also use letters such as g, h, j, and k to name functions like this. Let's try to look at this example and see how we can name a function. Over here, we want to represent height as a function of age. So we use h as a variable for height, and f as a variable for the function, and a for the variable for age. Now we want to name the function f. So we use h equal to f of a. So we use parentheses over here. We use these parentheses to indicate the function input. Remember, this is the input and this is the output. This is how the function is structured. Now, once we name this function, we read this as f of a. So height is a function of age. So a quick note over here that as we write the function as h equals f of a, this a is representing the input value. Which is just this portion. This is our input. Once we plug in the input, we get the output, which is our h. And h is same as f of a. So h or f of a represents the output. In Algebra 1, most of the times our function will be represented using the variable x and y. And the letter that will be used to represent this function will be f. This is a typical scenario that will be observed most of the times. And here, this output y will be depending on this input x. So y varies depending on the value of x. Now we'll see how to evaluate function like this. Over here, we need to evaluate f of x, which is equal to negative 4x plus 7. So this function, which is typically y equals negative 4x plus 7, we have just changed this y into f of x, and we want to see what is the value of the output when the input is x equals 2 and the input is x equals negative 2. Now, how can we find the output from the input? So here is the quick strategy. We just replace the x in the function with each specified value. Because the input value is a number 2 and negative 2, we can use simple algebra to simplify. So let's see how we can do that. So first, we just write down the function f of x equals negative 4x plus 7. Now we can see that this is my input and this input corresponds to this x. So we'll just replace this x with the input value 2. And we'll just replace this x with 2 as well. Now we'll do the simple algebra. So negative 4 times 2, that is negative 8 plus 7. Negative 8 plus 7 is equal to negative 1. So this is my output for the input x equals 2. So you can write f of 2 is equal to negative 1. Now we'll see how to get the output for x equals negative 2. Again, we follow the same strategy. So just write down our function f of x equals negative 4x plus 7. And we simply replace our x with this input, which is -2, and then we simply replace this x on the function with -2 as well. So -4 times -2 is equal to +8 plus 7, which gives 15. So you can say that when the input is -2, our output is 15. This is how we find the output value or evaluate the function using the given input. Let's see how we can solve this problem over here. The function f is defined on the real numbers by f of x equals 2 plus x minus x squared. What is the value of f of -3? Over here, we'll apply the same strategy. So first, we just write down our function f of x equals 2 plus x minus x squared. And now we'll just replace this x with -3. So I'll just use a different color over here. Now, as we replace this x with -3, we'll replace all these x with -3 as well. So we have 2 plus, instead of x, we just use -3 minus, we just use -3 here as well. Now we take the square. So you can see that we simply replace each x with the given value. Now let's try to evaluate over here. So f of -3 is 2 plus -3 is gonna be 3 over here. So we just distribute the sign. Minus -3 whole square is +9. Now we distribute the sign again. F of -3 is equal to 2 minus 3 minus 9. So if we just take the sum over here, we get -10. So you can see that our output value for the x equals -3 is -10. So remember, this is the input. And this whole section is the output. Now let's look at this practice example. Tom's little sister Emily is growing at a steady rate. The function f of t is equal to 5t plus 80 represents Emily's height, h, in centimeters at any given time, t in years, since she was born. The first problem, determine Emily's height at birth when t is equal to 0. And the second problem is find Emily's height when she turns 3 years old. So let's look at the first problem over here. We know our function is basically over here. This is h, which is the main output variable or the dependent variable. So h is equal to f of t. And this t is our input. So you can write down this function 5t plus 80. At the time of the birth, the t is basically 0 since that's the starting point. So we replace t with 0. Once we plug t with 0, we just replace this t with 0 as well. So 5 times 0 plus 80, which simplifies to 0 plus 80, which is 80. So in this case, our output is 80. In terms of words, we can say that this is 80 centimeters because the height is represented with centimeters. Now the second problem says find Emily's height when she turns 3 years old. Now the time is t equals 3. We apply the same strategy. We have this function f of t equals 5t plus 80, and we just replace this t with 3. So over here we just replace this t with 3, and once we replace this t with 3, we just replace this t with 3 as well. So now we have 5 times 3, that is 15, plus 80, this is equal to 95. Now that means it would be 95 centimeters because the height is expressed in centimeters over here. And there you have it, the magic of function notation. It might seem like a small part of algebra, but mastering it opens doors to more efficient and clearer mathematical communication. It is a powerful tool that transforms the way we express and understand mathematical relationships. That's it for this video, and I'll see you in the next one. Now let's get to study.